Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Dear students, welcome back to this 30 minutes lesson session. I'm teacher Patrick, and this time around I'll be working with senior threes in chemistry as usual. And we are dealing with unit number 6, which is the chemical properties of acids and bases. In the previous lesson, you remember, we were talking about the acids, which was lesson number 1. We talked about the chemical properties of the acid, but basically we are talking about the behavior. It was just a review about the acids and bases, because we had looked at this, or you had looked at this in senior 2, I believe so. And we're just going through the behavior, looking at the behavior of different acids. And we mentioned a number of acids, if you can remember. Can you still mention? I hope you have your notebooks and pens ready. Write down some of the acids that you remember that we talked about. So there are two, mainly there are some acids that we mentioned. We mentioned hydrochloric acid. Hydrochloric acid, this is found in the stomach. It is responsible for the action of the enzyme, of the pepsin enzyme, so it helps in the digestion of the food. So hydrochloric acid, you remember the formula for hydrochloric acid? That is H, capital C, and small r. So we talked about the nitric acid, which is HNO3. We talked about the sulfuric acid, which is H2SO4. I hope you still remember this. The senior 3s, I hope you should not be having any problem with these acids. So these are mineral acids. These are mineral acids. And then we have some other acids. So we mentioned about the ethanoic acid. Ethanoic acid, which is CH3COH, and which is the main component of vinegar. So whenever you're making salads, most of the time, you find you are adding the vinegar. So the main component in this acid, the main component in vinegar is this ethanoic acid. Then we mentioned about even methanoic acid, which is HCOH, and some other acids. This methanoic acid is found in the stings of the bees. When the bee bites you, you may even sweat. So make sure you don't come close to the beehives, because they may bite you. And once you are bitten by the bee, it injects you this acid, injects in your skin this acid, causes the sweating and the pain. That is methanoic acid, and some other acids. So these are examples of the organic acids. And then we mentioned that these acids, some of them are weak, so these ones are strong. The mineral acids, mainly, when we talk about the mineral acids, then these are strong acids. And then the organic acids are mainly weak acids. So you remember we even tested. We are looking at how you can test whether the acid is strong, whether the acid is weak, by using the conductivity. How fast can it conduct the electricity? We even mentioned, if you can still remember, we said we're looking at how acids, how can you tell that a substance is an acid or a substance is a base? And you remember we used different ways. We mentioned different ways. You remember them? Good. So we mentioned about the indicators. Can you mention some of these indicators? So these indicators, some of them are natural, others are artificial. So we mentioned the common indicators that we found in the laboratory, which we said the litmus. We mentioned about the litmus paper or solution. So this one, some will have the litmus paper or solution. Some of the litmus have some pieces of the litmus paper. Red, so I have the red here, and then I have the universal indicator. The universal indicator. So you use the universal indicator to test whether the solution is acidic, basic, or neutral. So this is the universal indicator. And you see the universal indicator has got a pH scale. And we also talked about this pH scale. It indicates the acidity and the alkalinity or the neutrality of the solution by using the papers inside here. So you see there is a scale over there. And with different colors. So ranging, you see there is 1, 2, 3, up to 14. So these colors, as we mentioned, indicate the color corresponds to the pH of the solution. The acidity, alkalinity, or the neutrality of the solution. If the solution is basic, with 14, with pH of 14, it will be, this is violet. And if it is acidic, then it will be red. And you see the water, which is neutral, is close to that neutrality with green color that is indicated, right? So we mentioned those indicators. We mentioned other indicators. The phenolphthalein indicator. Phenolphthalein indicator. We mentioned about the methyl orange. And I said, if you remember very well, that the indicators are so many. We have so many indicators, but we mentioned these common ones. So these ones are used to test whether the substance is acid or base. So if in case we don't use any one of these ones, then we can use either the pH meter. So the pH meter, I think I showed you the pH meter in the diagram. I didn't have the pH exactly, the real pH meter, but I think I showed you. You insert in the solution, so it reads directly the pH of the solution, and the pH corresponds to the acidity or the alkalinity or the neutrality of the solutions. This time around, we're just going to look at the chemical properties. How do these acids and bases react? How do they react? Those are the chemical properties. And by the end of this lesson, we should be able to write equations to prepare acids. Those are different acids, of course. Write equations to show how acids and bases react. So we'll start with, for example, in the chemical properties, we are going to see how either this sulfuric acid is prepared, how hydrochloric acid is prepared, how nitric acid is prepared. Maybe we may not be able to look at all the other acids, but we'll be able to look at the preparation methods for the acids, and then look at the chemical properties. Before we look at the chemical properties, we should be able to prepare. Then we'll be able to write equations to show how these acids react and the bases. So right away, we are starting with, let's see, our preparation of hydrochloric acid. So how do we prepare this hydrochloric acid? Over here, I will just do a very simple demonstration to show the preparation of this hydrochloric acid. So it is prepared from the reaction between sodium chloride, potassium chloride. So any salt of the group 1 metals can be used. This is sodium chloride over here, which I'm just going to use. And then I just put it over here in the test tube. And then this reacts with concentrated sulfuric acid. So I will react this one with concentrated sulfuric acid. And over here, I have water. So I will tell you why I'm using the water. So I'm correcting this gas over water. How do I know this is water? So I just want to confirm to you that this is water. So I'll use the indicator paper. This is, as I said before, this is a universal indicator. So the color that is corresponding here, I said if it is water, water is neutral. This is not purely water. So would expect to get, I would see the color of this substance. So if we insert it in, let me just look for another bigger one so that you can be able to see it. Oh. So I just insert in this indicator paper in the solution for some time. So when you look at the indicator, you see some green color coming over there. If you can be able to look at it, there is some green color that is coming. Look at this. Look at the indicator. There is some green color that is indicated. So that green color is, you see the color is coming. So the pH scale tells us that this solution is water because of the green color that is indicated on the pH. So the neutral solution here is indicated by the green color. So this is the water, and I'm just going to add some drops. Also, I will have to pass this one into, so I will have to add concentrated hydrochloric acid. This is a concentrated solution of hydrochloric acid, and then have to pass the gas, so the bubbles. So the bubbles indicate that the gas is produced. So the bubbles over here indicate that the gas is produced. There is some gas which is escaping over there, some little gas that is getting away. So there is some gas that is escaping, and it is coming over here. So that gas that is coming, if we insert another litmus paper, either the indicator, so I'm just going to drop another indicator here. So I have to add this, so it just goes inside. So when you look at this indicator, it is somehow turning to yellow, orange, red somehow. So there is no green color in there. If you can look at it properly, there is some reddish, orange color that is coming in. And what does it mean? The little hydrogen chloride that is formed over there, the little hydrogen chloride that is formed. So there is another way that we can tell this is hydrogen chloride, because we have said this is another solution that we can use. See what is happening. What do you think this one is? So this is another way we can tell this could be hydrogen chloride that is being produced. Why? So what is happening here is this. You having sodium chloride, which is solid, it is reacting with concentrated sulfuric acid in the other flask. So this reaction produces the hydrogen chloride gas. Hydrogen chloride gas. You remember we are preparing hydrochloric acid plus sodium hydrogen sulfate. The solution, that one will remain in the flask. So this hydrogen chloride gas, the hydrogen chloride gas is passed over water. That is why I was passing it over water. So it forms the hydrochloric acid. So the solution that I have here is no longer water. It has changed now because I've passed the gas into here. So it has changed into hydrochloric acid. So you can as well use, apart from sodium chloride, you can use potassium chloride, reacting it with concentrated sulfuric acid. So this will give potassium hydrogen sulfate, then plus the hydrogen chloride gas. Pass the gas over water. When the gas is passed over water, you'll get that. So the other concentrated, the other acids that can be used, there are other, we have mentioned, I said we have to prepare hydrochloric acid, we have to prepare nitric acid. So let's see, how do we prepare the nitric acid? So this is what I'm just talking about. I'm just forming the reaction. Hydrogen chloride is being formed. After being formed, we're able to test whether it is hydrogen chloride. Oh, something I was just going to forget here. You see, when I brought this bottle, and you remember when the gas was still coming, there were some fumes of the gas. Let me check whether the fumes are still there, whether the gas is still over there. No, the gas is over, so that is no problem. So the fumes that we have seen, so the hydrogen chloride gas, when it reacts with this was ammonia gas. So this bottle here is full of ammonia, and then some fumes of ammonia gets out. So this forms ammonium chloride, and ammonium chloride is formed. So ammonium chloride is a sublimate. The gas changes, so when it cools down, it changes into the solid. That's why so these are the white fumes. So I just want to remind you that this is the test for the hydrogen chloride, white fumes of ammonium chloride. So this is the confirmatory test for the ammonium chloride. As we are preparing hydrogen chloride, we can be able to test whether. So the nitric acid is prepared from nitrates of group 1, the nitrates of group 1, that is sodium nitrate, reacting with concentrated sulfuric acid. Concentrated sulfuric acid. This must be the condition for the reaction. So this will form sodium hydrogen sulfate and then plus the nitric acid. So this is the test. Sodium nitrate and concentrated sulfuric acid. So those are some of the reactions that can be used. So I said, instead of using sodium nitrate, you can use potassium nitrate. Potassium nitrate plus concentrated sulfuric acid. So this reaction also gives the potassium hydrogen sulfate plus nitric acid. So that is another reaction that can be used to prepare this acid. Remember, potassium nitrate is preferred. It is mostly preferred. Why? Because this sodium nitrate is hygroscopic. It can absorb the water from the atmosphere. And what does that mean? So when it absorbs the water, it dilutes the acid. And one of the conditions that I mentioned is that the acid must be concentrated. So this time, if you use sodium nitrate, because of its hygroscopic properties, it will absorb the water and then dilutes the acid. You may not be able to get the concentrated acid. So here, potassium nitrate is preferred because it is not hygroscopic. So before we look at that one, I just want to mention about the sulfuric acid. So the sulfuric acid is not prepared in that way. So when we have sulfuric acid, so this is prepared from the oxide, so there is no direct way of preparing sulfuric acid. Only sulfur dioxide reacts with oxygen. This forms the sulfur trioxide. Remember, this reaction takes place when we are discussing about the unit 3, the sulfur and its compounds. I think we could have mentioned about this. Remember, on unit 6, so I expect you to have discussed that one. So sulfur trioxide reacts with the water to form the sulfuric acid. So, but even this reaction is not preferred because it forms a mist of the acid, which it is highly exothermic. So usually, the sulfur trioxide is mixed with the orium. Is mixed with orium. I'm just trying to remind you about this. It is mixed with the, oh no, I beg your pardon. Oh, it is mixed with a little concentrated sulfuric acid, and this forms the orium, fuming sulfuric acid. So this fuming sulfuric acid reacts with water to form concentrated sulfuric acid. Concentrated sulfuric acid. Now, that is how it is formed. That is sulfuric acid. No direct method. Actually, this one is referred to as contact process. Contact process. I believe that you could have looked at this one before. So let's look at some other reactions. Reactions of bases with water. The oxides, that is preparation of bases. We have different bases. So from oxides mentioned about, so these are the soluble bases. Soluble bases. For example, sodium oxide will react with water to form sodium hydroxide. And you may have either potassium oxide reacting with water to form potassium hydroxide. So this one way of preparing this. Or you may have some other methods where metals react with water. I hope this was just a review, so I can just remove this. So looking at the other methods of preparing these oxides, you have either metals, sodium reacting with water. This will form sodium hydroxide plus the hydrogen gas. I've done this experiment several times, many times. Or you can have potassium reacting with water. This will form potassium hydroxide plus the hydrogen gas. If we get time, then we'll be able to look at even some other methods. I've just talked about that, the reaction with water, giving up this colorless gas. So you can be even able to test using either any other method of testing the acids and bases, universal indicator. So let's look at the reactions of acids. The reactions of acids. Acids react with metals. And when they react with the metals, we had looked at this one. This is in the displacement reaction. In displacement reaction. And this is where you have either sodium with hydrochloric acid. This is where the metal displaces the hydrogen gas. And this forms sodium chloride plus the hydrogen gas. Other metals, you may have either zinc combining with sulfuric acid. Just give any other example. This will give zinc sulfate plus the hydrogen gas. Then you may have other reactions. So the reaction with the acids react with the bases as well. Or they react with the bases that we have mentioned can be either, these are bases as well, the oxides, the hydroxides are also bases. So for example, you have hydrochloric acid. This can react with sodium oxide. So this will give sodium chloride and water. So when they react with bases, now this is sodium hydroxide and sodium chloride and water. Good. So you may have either sulfuric acid reacting with any other base, magnesium oxide. This will give magnesium sulfate plus water. So bases react with acids to produce salt and water. Or they react with acids to produce hydrogen gas and the salt. So that is one of the reactions with calcium carbonate with carbonates. So we may have the carbonates reacting and hydrogen carbonates. So if you have, for example, calcium carbonate with hydrochloric acid, this will give calcium chloride plus carbon dioxide and water. Or the hydrogen carbonate, that will be either sodium hydrogen carbonate plus the hydrochloric acid. This will give the sodium carbonate, B2 plus carbon dioxide plus water. So those are some of the reactions of acids and bases. Then I've also mentioned that one. Then there is another important. Bases can be oxides or can be hydroxides. For example, HCl with the sodium hydroxide, this will produce sodium chloride and water. You remember the type of reaction is this? Said this is a neutralization reaction. Neutralization reaction. Neutralization reaction. Good. So I've mentioned about that. That is a neutralization reaction. Reactions of bases, which are similar to those of acids. And then some bases react with some amphoteric bases, react with sodium hydroxide to form those complexes. Sodium zincate, sodium prambate, sodium aluminate ions. And then I won't leave without giving you an assignment. I would wish that you just take a snapshot of that if you have a smartphone, so that you can be able to capture all the information. And lastly, this is what you are supposed to do. Go to e-learning platform for REB, look for student book of Senior 3, and then you discuss the uses and dangers of acids and bases in everyday life. So in the next lesson, when I come back, when I meet you, we'll be able to discuss this, but when you have already carried out the research. I thank you so much for watching and listening, and be with me in these 30 minutes. Bye-bye.